try to review it at home, this reasonment. And if we want to make the product A, B, I, J, where I equal 1, 2, M, J equal 1, 2, P is equal AI scalar product. Let me put it here in order to distinguish row by column with a super index instead than a subindex. Just not to make confusion, but I mean, it would be correct also if it was a subindex. B, P. So the product of an M by N matrix and a N by P matrix is a Milan by Padua matrix, M by P matrix. So it's row by or row times column matrix product. Obviously, you could define other column by row product, but it's not. It's enough to define one product. In Italian, sometimes it's called Rico product because is row is riga and co is for colonna, columns, which is neither than row time columns, but Rocco, in English, no, I've never heard to use Rocco product. But remember, dimensions are important. So let's consider this example here. And okay, here, and let me here. Okay, magic. Let's try to make some example. We are summing two matrices. The first one is 2 by 3, and the second one is 2 by 3. So we can sum them. It's extremely easy. Their sum is first entry 1 plus 0, 1 plus 0, 1. entry, second row, first column, 3 plus 0, 3. Then second column, second row, second column, 2 plus 2, 4. First row, second column, minus 1 plus 1, 0. I know it's straightforward. Third row, second row, third columns, 8 plus 3 equal 11. And first row, third column, 4 plus 1 equal 5. Then the second example, I'm going to leave it a moment, but I think the sum is straightforward. But obviously, you need to review it. Then let me copy. And let's multiply the two matrices. But first of all, we have to check that we can. The first one is a 2 by 3 matrix, 2 rows, 3 columns. The second one is a 3 by 3 matrix. So the number of columns of the first is equal to the number of the row of the second. So call it A and call it B. A times B is A times B is a 2 by 3 matrix. So let me rewrite. For the first time, it may be productive to write explicitly the row and the column vector. So the first row vector of A is 1 minus 1. For the second column vector of A is 3, 2, 8. Then we have to write, or we may prefer to write, the first column vector of B. You can write, for instance, here, this. B1 equal 1, 1 minus 1. In some sense, vectors are matrices. You can represent them as a row matrix, a 3 by 1, in this case, matrix, or column vector can be seen as three by 1 matrices. In this way, the inner product would be a particular case of a row by column product. You multiply a 1 by 3 matrix by a 3 by 1 matrix and obtain a 1 by 1 matrix, which means a number. B2 is 2, 4,